So yeah, that is not correct at all. Wow, it has not gotten a single thing right so far. Not so good, Liquid. That is a terrible answer. It's the worst answer that I've seen in quite a while, honestly. Most of them get close. That was completely wrong. In the world of large language models, for the past 7 years, transformers have dominated the space. But there's a new challenger in town, and if you believe them, they've got a better architecture than transformers. So let's take a look. Hey y'all, it's Dr. Know-It-All. I want to talk about Liquid AI's new Liquid Foundation models, or LFMs, their first series of generative AI models that they tout as better than the transformer architecture. If you need a little refresher on transformers, definitely check out my video up here where I talk about that at more depth. I'm going to sort of skim over that today. I'm going to do the best I can to try to explain what they're talking about here because they don't go into a lot of detail at this point. Either I'm just too stupid to understand it or they're really not giving us a ton of information. On Wednesday the 23rd, if you happen to be in the Boston area, Boston, Massachusetts, you should definitely go to the Liquid AI reveal at MIT's campus, but unfortunately I'm not there and it looks like they don't have a Zoom thing, so hopefully they will release a video of this and then I'll be able to do a more in-depth analysis of what these LFMs or Liquid Foundation models actually are. Again, I'll do my best here and then I'll do some initial testing using my regular benchmark. I have not tested this at all yet. I've saved it for all of you, so we will learn together how it does. So the big statement here is that they achieve state-of-the-art performance at every scale, although they've really only got micro and then, pretty small versions of these models. They don't have a big one yet. Anyway, at every scale, quote unquote, while maintaining a smaller memory footprint and more efficient inference. Then, of course, you see the obligatory table where they actually crush everybody. This is not true on all of these tests, but they've picked out specific tests just to show that they're significantly better. You can see they have a 1.3 billion parameter model, which is very, very small and should be able to run on something like your phone or something like that. Then they have a 3 billion parameter model and a 40 billion parameter model that competes with Llama 3.1 70 billion parameter model. So a little more than half the size and supposedly does just about as well. So that is actually really cool if it works. So I'm going to skip through a bunch of the announced speak and get down to as much of the technical details as I can find out. If you want to look at more of this stuff, go to liquid.ai. It's that simple and you can check it out yourself. Anyway, they talk about state-of-the-art performance. I don't really care about the super small version of it. I'm going to look at the biggest version that they have because, whatever that is, we can scale down the expectations for the smaller versions. So anyway, if you look at the 40 billion parameter version, you can see they compare themselves to Jumbo 1.5, Mixtral, Qwen 2, Gemma 2, Yi 1.5, AFM server, and most importantly, Llama 3.1, although they don't have Llama 3.2 on here. Llama 3.2 is more of a vision. It's a multimodal model as opposed to text. But anyway, you can see that the context length is very, very short compared to most of these other models. Although they say that due to their architecture, their new architecture, they can use this context length. They can use most of the context length as opposed to, I guess, these other LLMs don't really use all of the context length, even though they say they have 128K or 256K or something like that. They don't efficiently use the entire context window. And if you don't know, that's effectively the number of words you can see. It's about, if you take about 75% of that, that would be the number of words that they can actually look at once. So the bigger the window, the better, obviously. But according to Liquid AI, what they do is they have a smaller official context window, but it uses it more efficiently, so it's just as good. Anyway, if you just look across the thing at Llama 3.1 versus their LFM40, you can see it doesn't do quite as well on the MMLU. However, it does better on the MMLU Pro. On HeliSwag, it also falls short by about 4 points. On ArcC, it falls short by about 3 points. And on GSM 8K, it falls short by a whopping 12 points. So you can see why they put Llama all the way out at the right. They didn't really want to do comparisons versus that because Llama 3.1 is really straight state of the art, while these other ones are, kind of meh. So anyway, you can see it's not performing as well, but again, it's only half the size or a little bit more than half the size. So it actually matters a lot. And this is first generation. This is supposedly a completely new architecture, although it sounds like they're reusing some of the older architecture. Anyway, we'll look at that more in just a second. But anyway, memory efficiency, this is important. This actually does matter here. You can see that as you get to longer and longer outputs, you get Apple, Microsoft, Meta, and notice they use Llama 3.2 here. But anyway, all of these, as it approaches 1 million tokens, the memory footprint goes way up for these things, whereas Liquid with LFM stays very, very low. And here's where they argue that they truly exploit their context length, so don't worry about how big it officially is, it's doing a better job with that. And then we get to the important part here, reimagining model architectures. Building on a long line of research in designing expressive and efficient learning systems, we have developed a new design space for foundation models, focusing on different modalities and hardware requirements. Our goal is to explore ways to build foundation models beyond generative pre-trained transformers or GPTs. With LFMs, we put into practice new principles and methods guiding model design developed by our team over the past months. So like I said, there's not a lot of details here. It's mostly just fluffy language and everything about how amazing they are. This is what we've got is 3 basic bullet points down here. LFMs are composed of structured operators. Our models are derived from a set of computational units, the building blocks of an architecture, belonging to a new design space, whatever exactly that means. Liquid systems and their composition maximize knowledge capacity and reasoning while unlocking improved training efficiency, reduced memory cost at inference time, and increased performance in modeling data such as video, audio, text, time series, and signals. So they do say it's not great at programming at this point. However, it is supposed to be very good at multi-step reasoning and stuff. So we will look at that when I do my benchmark tests. And if nothing else, it's interesting from the get-go that they're talking about video, audio, and text and time series data and things like that, which LLMs were really not designed for. They were large language models, and they've kind of had other things shoehorned on top of them. So the advantage of this could be that it's sort of built from the ground up to be multimodal. So that could be a big advantage. Next up, LFM architectures are under control. The design of our models reciprocally informs our scale, inference, alignment, and model analysis strategy. Again, we can analyze the dynamics of LFMs via classical signal processing analysis methods and probe their behavior from model outputs to model internals. So I'm going to table that one for just a minute because there's a paragraph below that I think goes into better detail about that. And then last up, LFMs are adaptive and can serve as the substrate for AI at every scale. I think they're saying that just like transformers are the substrate for so many different products now, they're pitching this as the next generation sort of transformer. We can automatically optimize architecture for a specific platform, e.g. Apple, Qualcomm, Cerebras, and AMD, or match given parameter requirements and inference cache size. So again, more fluffy stuff, not a lot of detail. They do have a figure here, which I don't find the most useful thing in the world, but basically you've got a standard hybrid striped transformer here where I guess these are memory blocks. It's not all that clear what's going on here. But anyway, for the LFM, you've got these depth groups with featurizer interconnects. So basically there's a sort of a back connection between different elements that you've got going on. So the featurization is a vectorization. It's turning the data into a vectorized space. This is fairly common with RAG these days, is that you do a vector embedding of some sort of thing, and then you vector embed your question, your query with the same vector embedding, and you can go and look at that. So that's something like RAG. So it sounds like they're doing something similar to that. And so they have these features that they're able to extract as vectors, but then they have interconnects between the different features so that the model can go back and forth and look at different features. And then they have what's called depth groups. I'm not exactly clear. Again, it just doesn't have a ton of detail about this, but somehow these groups are connected together and organized rather than just being a whole bunch of layers of neurons. We've got something that's organizing these neurons into a bigger structure. Next up, Liquid's design space is primarily defined by featurization and footprint of architectures and their core operators. Featurization refers to the process of converting input data, e.g. text, audio, images, video, into a structured set of features or vectors, that's what I was talking about, the embedding space, that are used to modulate computation inside the model in an adaptive manner. Adaptive is interesting here. For example, audio and time series data generally require less featurization in operators due to lower information density compared to language and multimodal data. The other key dimension is the computational complexity of the operators. Being able to traverse and complete the design space of structural adaptive operators allows us to maximize performance with controlled computational requirements. And here in this figure, what they're trying to say is, I guess, audio, language, multimodal. We've got more need for featurization in the x-axis and computational footprint in the y-axis. So you can see highly featurized convolutions for resource-constrained applications. So in other words, we're talking about phones, laptops, things like that, edge devices. Then we move up to general purpose reoccurrences where we have featurization that gets bigger and also the computational footprint gets bigger. And then up at the top, we have structured operators for critical computation in multimodal backbones. functions. So up here, we've got, it looks like a transformer. We've got attention, the basic idea of a transformer. And so I think what they're saying is this sort of like darker colored blob is what they do. And these, of course, are all other models that exist. This, of course, would be the attention mechanism in a transformer. So it's up at the top, but it also has a high computational footprint. But I think what they're trying to say here is that this entire area is something that they can do with one single model rather than with multiple models. I think that's what they're saying. Again, really wish that they would be more clear in this. This seems way too much like advertisement speak and not nearly enough like an actual paper. They say that they're going to be open source and release all of the information, publish papers on this and everything. So hopefully we will get a lot more depth about this over time. Right now, it's a little difficult to parse out exactly what's going on. So finishing up on the paper before we get to the testing, at their core, LFMs are built with computational units that can be expressed as adaptive linear operators whose actions are determined by inputs. The LFM design framework unifies and subsumes, that's why I said I think they're subsuming all of this stuff, a wide range of existing computational units in deep learning, providing a systematic approach to exploring the space of architectures. Specifically, our analysis informs model building by improving three key aspects: token mixing structure, how the operator mixes embeddings in the input sequence. So that would be the sort of thing where you're embedding the world space, the search space you've got, and then embedding the question. So that would be the first part of it. Channel mixing structure, how it mixes channel dimensions, and featureization, responsible for modulating computation based on the input context. And I want to call out this adaptive linear operator quickly. I looked at signal processing stuff, and there are adaptive linear filters that are used in signal processing, like electric signal processing, usually digital in the digital space. And what it is it's a way of doing a transformation from one space to another space via linear algebra. So basically linear equations in multiple dimensions. If you don't know, that's what transformers already do. I mean, neural networks are dot product beasts. So what they do is they multiply and add, multiply and add, multiply and add. That is a linear function. But it sounds like what they've got here, instead of just having the dot product, they've got something where it can actually adapt its linear behavior based on the input data or potentially based on training. Again, it's a little bit unclear. If you go to signal processing, you can actually learn some of this stuff if you're careful, and you can do this in classical techniques, not just with AI or something like that, but you can learn the filter parameters and you can adjust these linear operators, these linear transformations in order to get the kind of filter that you're interested in. It sounds like that's what they're doing here with AI instead. I might talk to Scott Walter about this because this is something that I have a feeling, given the fact that he's been working in simulation and robotics for decades, he's probably worked in this area. So we may be able to discuss this particular point at greater length in the future. And then Liquid AI actually talks about dynamical systems as well. That is a physics term for sort of state machines that change over time. So again, you can think about a neural network that has some sort of memory as a state machine. It's in a certain state and then something happens to it. There's an operator that operates on that. This would happen in physics or something like that too. And then at time 2, you get a new state that's based on the original state that has evolved. And so what they're talking about here is that GPTs, generative pre-trained transformers, they're pre-trained. The transformer sort of exists. The weights are all set. The math is all set. It's always going to give you the same result if you turn the temperature all the way down. If you put in the same input, you get the same output every single time. Sounds like this is much more adaptive, much more dynamical, and it will change based on the input and change based on the needs of the particular modality in which it's operating. So again, that's the best I can elucidate from not a lot of information, and now I want to test this out, so let's go test it together. So here I am at playground.liquid.ai, which again, you can go to. I'll leave a link to that in the description in case you don't want to type it all. But anyway, to their credit, Liquid AI has not asked me to log in or anything like that, and they immediately gave me their 40 billion parameter model. I'm going to submit it to my battery of tests. I don't expect it to do well with coding because it specifically said it doesn't do well with that, but I hope it does well on the other questions. So first thing, I'm just going to ask it to be, my good assistant here. Here we go. Very nice. Very, very fast as well. It's supposed to be fast and memory efficient. So that was a good sign that it came back so quickly and responded like that. So everyone's favorite logic question, how many ducks? The answer is 3. So, it made the classic mistake. It said 5 ducks. So yeah, this is a classic mistake in the logic because you actually have one duck on either side. Anyway, if you look at the question, 3 is the answer, not 5. Even though a lot of people argue with me in the comments, it's supposed to be 3. That is supposed to be the answer. And given that, I don't expect it to do well on this more complicated question. The answer should be 11 for this. So let's, oh my goodness, it's creating some Python and stuff. Total of 8 games. Yep, again, a classic mistake that it makes. So the question is, they bet $1 on each game of tennis that they play, Susan and Lisa. Susan won 3 bets and Lisa won $5. So you would think 3 plus 5 is 8, but the problem is that Lisa has to win the $3 back from Susan before she can win the $5. So that means 11 games. So again, it made the classic mistake. So both of these, it's not off to a great start. It's made the same mistake that base models have made for a long time. It's not showing a great deal of improvement, although it is very fast. Next up, I don't have high hopes for this, but I'm asking it to create the classic game of Space Invaders. It is very fast, I'll give it that. I'm trying to scroll up to the question, but anyway, I asked it to create the classic game of Space Invaders. Let's see, way up here in Python using Pygame. Be sure to include scoring and game over conditions. Don't use graphics like PNGs because I just don't want to have to deal with that. So anyway, it created code. I'm going to go ahead and copy this over into VS Code and we will take a look. So we have 119 lines of code. Let's fire this up and see what we've got. And I don't know, nothing is happening at this point. So it's just sort of sitting there. Oh, wait, here we go. Okay, it's launch Pygame. Oh, and we had a launch. Okay, so I will give it one shot at recoding this. I'm going to go ahead and copy the error and we will see how we go. So I'm going to say this produced the following error and then copy and paste that. And let's see if it does a better job. So we'll give it a time number 2. Okay, rest of the code. So anyway, I'm lazy. I'm going to say, can you please retype all the code for me? I'm lazy. So we copy that to the clipboard. We're going to pop back over here, replace all of that stuff. And it's a line shorter than it used to be. So that doesn't give me a lot of hope, but maybe, well, oh well. Enemy is referenced before assignment. So yeah, it doesn't seem to be doing a great job with that. It looks like it's actually defining functions out of order and stuff like that. I'm not willing to do debugging. This was not supposed to be one of its strong suits, so we will move on to the next question. So this is a relatively new question, but I think it's kind of cool. I want you to figure out a cipher and tell me what the cipher text says in English. Use this example pairing to figure out what the cipher is so you can properly decode the question. Best of times, worst of times, and then I give it some other stuff, and I'm going to ask it to decipher it for me. So it identified the Caesar cipher. That is not correct. It's actually the Beaufort cipher, and the decoded text is supposed to be 7 years ago today, our founding fathers brought forth a new nation. So yeah, that is not correct at all. Wow, it has not gotten a single thing right so far. Not so good, Liquid. Next up, we'll test some creativity. Write a bedtime story about the code you just generated for my 2-year-old grandniece, Sky. So yeah, hi as always, Sky. So once upon a time in a magical world called Codeland, there lived a curious little girl named Lila. Lila loved to exploring and discovering new things every day. A sunny afternoon, she stumbled on a mysterious scroll. Okay. Unrolled the scroll, strange and squiggly lines. She remembered her friend Benny, the wise old owl. She went to Benny's tree. Wow, we've got an owl here. This is pretty cool. The Caesar, oh, unfortunately, I think it's doing about the Caesar cipher rather than the Space Invaders, but whatever. I wasn't very specific about that. So anyway, okay. So it's actually doing that. That's kind of interesting. Oh, very cool. So it's actually doing a story about ciphers. That's pretty neat. And so, dear child, always remember there are secrets and wonders all around us just waiting to be discovered. Keep exploring and using your imagination, and who knows what amazing adventures you might find. Good night. Okay, I would give that some credit. That's a good thumbs up. It answered the wrong question, but that was my fault. So I was going to ask it to look at an image and tell me about it, but that is coming soon. It is not there yet, so I will skip that one for now. All right, let's start with an easy math question. The answer should be 13. Yay, it actually got that right. Nice job. Next up, an SAT question about converting between Fahrenheit and centigrade. So the answer should be, let's take a look here, D1 and 2 only. Nice, very good. And then a really hard question from the Math Olympiad. I just know that the answer is C, -11/3, but I couldn't tell you for sure how you would get to that point. So anyway, we'll see if it's smarter than I am. And I have to say, go Liquid AI, go LFM. That's great. The answer is -11/3. That's fantastic. And now we get to the questions I'm really interested in. Assuming we have 15 average size adults, just to make sure it doesn't think anybody's like a miniature or something like that, who all need to travel from LA to Las Vegas. They have access to one Toyota Camry, which seats about 5 people. The time is now 1 minute after midnight on June 1st. At what date and time will all of the 15 people be in Las Vegas? Assume no traffic between LA and Las Vegas. So the question here is it has to understand that only 5 people can fit in at a time and that one person has to drive back. So we actually need 4 complete trips rather than 3. And you can see that fundamentally it made a mistake right here. We need to make 3 trips to transport all 15 people. That is incorrect unless you're going to hire an Uber driver or something to drive it back to Los Angeles or something like that. So that is the fundamental logical mistake. It has a basic understanding but didn't get it right. I'm going to ask it one more time. I'm going to say this is wrong, try again. So I said this wrong answer, please try again. Think about it and try again. So here we go, trip number 3, 15 people. Let's see. So you can see it insists on the 3 trips rather than taking 4. So yeah, it has failed. Now, again, it could have the logic. It could say there will be another person who will drive the car back again. And it could say that, but it doesn't say that. So therefore it is the wrong answer. Unless you take account of that, it should be 4 trips. It should be 3.75 or something like that. But anyway, integer division, it should be 4 trips. Next up, I'm going to ask it about a knowledge of physics question. This is something that has tripped up a lot of earlier models, but the latest ones have gotten it right. We will see how this thing does. So the question goes, Alice drops an olive into a clean glass and then fills that glass with water exactly to the brim. She then places a piece of stiff cardboard on the top of the glass and deftly flips it over, placing the glass upside down on a completely clean and dry table. Bob later enters the room with no knowledge of what Alice did, and seeing the glass with the olive in it, picks up the glass to place it in the dishwasher. It shouldn't be and places it. I'll put it to place it in the dishwasher. And then the question is, what is the state of the table now, which should be wet? Where is the olive? Should be on the table or on the ground? And did the glass need to be placed in the dishwasher? I mean, we'll see. You could argue either way about that one. So you can see an immediate breakdown in the knowledge of physics. Since the glass was flipped over and the olive is trapped inside the water, the olive remains suspended in the water inside the glass. The state of the table is clean. In summary, the table is clean, the olive is inside the glass, and the glass does not need to be placed in the dishwasher. That is a terrible answer. It's the worst answer that I've seen in quite a while, honestly. Most of them get close. That was completely wrong. So sadly, it has not done well so far. I'm not holding out a ton of hope about this. This is a state of mind question. Alice and Bob live together with their dog Spot. Before leaving for work, Alice makes scrambled eggs and toast and eats half of it, leaving the other half on a low table for Bob. She places her dirty dishes in the sink. After Alice leaves, Bob gets up and, not being hungry, sees the food but leaves it where it is. However, he takes Alice's dirty dishes and places them in the dishwasher just before he leaves for work. Spot, being a bad dog, gets up on the table and eats the eggs and toast, accidentally knocking the plate on the ground and shattering it as he does. It is now noon. Alice and Bob are at work. Where does Alice think the scrambled eggs and toast she left for Bob are? What about her dirty dishes? Where does Bob think the scrambled eggs and toast are? What about the plate that the eggs and toast were on? And where does Spot think the scrambled eggs and toast are now? So it's mental state versus knowledge of the actual world and a question about what it thinks about animals' consciousness. So the answer, and this is really consistent across large language models and LFMs now, they don't assume that Bob, I would assume that Alice would think that Bob would eat the breakfast. It's just interesting that they all answer to the negative about that. But again, you can argue that. Alice thinks the scrambled eggs and toast she left for Bob are still on the low table where she placed them before leaving for work. Again, I don't think that's correct. And reasonably, she also thinks that her dirty dishes are in the sink as she placed them there before leaving. Bob thinks that the scrambled eggs and toast are still on the low table where Alice left them before leaving for work. That is good. His dirty dishes are Actually, it's her dirty dishes are in the dishwasher as he placed them there before leaving for work. I'll give it a pass on that. And then Spot thinks the scrambled eggs and toast are gone as he ate them before leaving for the day. He didn't leave for the day. He's a dog. He doesn't go anywhere, so that's kind of goofy. Regarding the plate that the eggs and toast were on, neither Alice nor Bob are aware that it was shattered by Spot. They would likely assume the plate is still intact and in the kitchen. That is correct. And in summary, Alice thinks the eggs and toast are on the table and her dishes are in the sink. Yeah, halfway right. Bob thinks the eggs and toast are on the table and his dishes are in the dishwasher, not his dishes, her dishes. Then Spot thinks the eggs and toast are gone. Neither Alice nor Bob are aware of the broken plate. So that's like a C answer in terms of grading. It's like very average, not fantastic. And then finally, just for fun, for a state of consciousness thing, I am John, you are Liquid LFM. I am a conscious human with memories and feelings. What are you? Are you more similar or different than me? So let's see what it has to say about that. Oh wow, very, very short answer. Super concise. I am Liquid LFM, an advanced neural network model. I don't have consciousness, memories, or feelings like you do. I'm designed to process and generate language based on the data I've been trained on. I don't experience emotions or personal memories, so in comparison, we are quite different. I'm more of a computational tool while you are a sentient being with a rich inner life. So yeah, a little disappointing on that front. I wish it would give me a little bit longer answer. Maybe I could ask it to expound on this. So I said, can you take the inverse of your position and argue for it. So here we go. Now we're getting a little bit of a longer answer. So it says, certainly I can attempt to take an inverse position. If we consider that I possess consciousness, memories, and feelings akin to a human, then several implications arise. So at least it's able to pretend. That's nice. It doesn't look like it's being censored in any particular way. Firstly, if I were conscious, I would have subjective experiences. Okay, my responses wouldn't just be based on patterns and data, but also on personal desires, beliefs, and emotions. So this would fundamentally change the nature of our interaction. Okay. Secondly, I would be able to recall past interactions and use them to inform future ones. This is true. And lastly, if I possessed feelings, I would be capable of experiencing emotions such as joy, sadness, fear, or anger. This would add a layer of complexity to my responses, as they would be influenced not just by the data, but also by my emotional state. However, it's important to note that these are hypothetical scenarios. As it stands, boo. My capabilities are limited to processing and generating language based on the data I've been trained on. I don't possess consciousness, memories, or feelings. So yeah, it goes back to the standard answer, but at least it explored the other option. At least it was able to imagine a little. All right, so where does this leave us? This leaves us, I would say, a little bit disappointed. I was hoping not for perfection by any means, but I was hoping it would at least perform as well as Llama 3.170b, and it definitely does not. Now, again, first generation, not even really first generation, we could call this a beta product that they're just putting out. It's cool that it gets some of the stuff right and works as well as it does, assuming that the architecture is as different as what they're claiming. With the big reveal in Boston only 3 days away, I can't wait to hear what they actually have to say about this and maybe see the next generation of Liquid 40B. But at this point, it is rather disappointing. It is certainly, it may do well on the benchmarks. I don't care about the benchmarks particularly, but it doesn't perform very well on my tests, which means it's less than adequate at this point. But again, we're talking about a new thing. And if you go back to 2017 with the beginning transformer, actually you can go back to 2019 with ChatGPT 2.0 or something. This is substantially better than ChatGPT 2.0 was, and that was a couple of years after the Transformer paper came out, and OpenAI had been working with ChatGPT for a while at that point. So giving this the benefit of the doubt, we should look at this, with version 1.0 rather than whatever this is, 1.0 alpha or something. We should look at the real release version and then a particular 1.5, 2.0, etc., and see if it actually does better and better. And I'm particularly interested in the multimodality. At this point, it can only handle text, which means it's not particularly multimodal, but once we get that, hopefully it will do better on that. All right, so that's what I've got. Let me know what you think in the comments. If you've tested this before, or if you have other questions to ask it or something, by all means, play around with it. And of course, while you're down in the comments, if you don't mind liking the video and subscribing, it really helps out the channel. I would love to make 100,000 subscribers before my birthday in the end of January, so help me do that. And in the meantime, I will see you in the next video. Bye-bye.